Hola clase. Today we're going to see a way of dividing polynomials called the synthetic division, which it's a way of dividing polynomials that works much faster than the long division. And as usual, I'm going to give you a how-to step by step, and then we make an example together. Now, before we start, we need to know a couple of things. First, we need to know the remainder theorem, which tells me how to divide polynomials. And it tells me that if I've got a polynomial of any degree and I divide by a divisor, I will get a quotient and a remainder. And that remainder would be the polynomial of A. I need to know the factor theorem, which tells me that if x minus a is a factor, then p of a, which is a remainder, needs to be 0. And I need to know how to make the long division for polynomials, which is the one that this comes from. And the most important part of that part, I need to know that the exponents, the result for the x's, are actually going to be predictable. That's going to be a good thing because that means that I can leave them alone and focus on the coefficients. So now for the how to step by step. First, you need to find the factors. So find factors of the independent coefficient, and those will be the factors of the independent coefficient. Here you go. And those will be the factors of the whole thing. And for that, I just need to evaluate them and find one that gives me 0. Then you're going to make a box with only the coefficients. You're going to leave every exponent, all the variables, aside until you finish and work only with the numbers. And then you're going to divide by a. And the way to do it is the following. First, you always carry the first coefficient. That doesn't matter which one it is, you just carry it with you. Then you're going to multiply that value by a, and you put it in the next column. It will make sense once we make one. Then you're going to add that to what the coefficient you've got, and you're going to repeat until you reach the end, which could give you your remainder of 0 that you know should happen. Then if you need, you solve the polynomial. They may or may not ask you for that, but generally you could be doing this to solve it. Okay, let's see that in an example. They ask me to solve this. And once I see it, it's a cubic, which is a problem because we know how to work with quadratics and with linears, but cubics are a bit more painful. Right, the first step, I'm going to need to find factors of 8, which is the independent coefficient. And you've got plus or minus 1, plus or minus 2, 4, or 8. With that, now we're going to have to begin evaluating. And remember, evaluating, it's just substituting the x for the value in question and then see what that gives you. The important thing is that gives you 0. This is definitely not 0, so you need to keep on searching. If we do that, this is 0. That's a good thing. So now we're going to come here and create a box. I'm going to make myself a bit of space. And in that box, I'm going to copy the coefficients. Remember, if I don't see anything, there is a 1 in there. So I'm just going to copy it. And the signs are important too. I'm leaving myself a bit of space. And now this value of a that we found on here comes in here without changing the sign. I'm leaving the sign as it is. Now we're ready. This first coefficient always gets carried down. Doesn't matter what it is, we put it there. Then we're going to take these two, multiply them together, and put the result in the next column. In our case, -1 times 1, that's a -1. And then we're going to take these two and add them together. We will put that in our next place in here. -5 minus 1, that's a -6. And we're going to repeat the process. If we change colors here, we're going to multiply by a and bring it to the next column. In our case, -1 times -6 is a +6. And now we're going to add together. +2 + 6 + 8. Then we repeat the process. -8. And when we add it, that gives us a 0, which is a good thing. Remember, this is your remainder, which is a good thing. It's 0 because otherwise we will not have a factor. That tells me that all this cubic, x cubed minus 5x squared plus 2x plus 8 equals x, remember it's minus a, so plus 1 times the polynomial here. Now, if this was a cube, I know that this is going to be a square, and so on and so on. So I just need now to fill in the gaps, put the exponents that I knew were predictable, and just fill with the coefficients. Now, this here, it's a quadratic. So you've got options there. I could factorize or I could use a quadratic formula, but just to show you that the synthetic division works with everything, we could do exactly the same. Find factors of 8 and evaluate. I'm just going to go for one that I know it works. But if I do this, well, 2 squared minus 6 times 2 plus 8, that happens to be 0. So I could come here and repeat the same process. That's what this one is very handy for things that have a high degree. I can put the 2 here and do the whole thing all over again. The one I'm going to carry it, so it comes here, and then I will multiply these two and put them in this column. In our case, 2 times 1 is a 2. And then we will add together. -6 plus 2, that could be a -4. And repeat the process until we end. 2 times -4, that's a -8. And when we add them together, that's a 0, which is our remainder. With that, we've got now the whole thing that we had broken into a linear and a quadratic fully factorized. X plus 1, we never touch it. Oops, excuse me. Then x minus 2, because remember that this is a and this is x minus a. And then the result here is an x minus 4. And that one comes from here. 1x, not that we ever wrote that way, minus 4 is this one here. Well, now if all of this is 0, getting x, now it's very easy because it's just solving these three linears. X needs to be -1, 2, or 4. Now we solve it, we've got our result, we box it so it's tidy, and we're done. Okay, now it's your turn to go and practice. Thanks for watching.